solving trig equations in one rotation. That's going to be our focus today, and that's the purpose of this statement here, going from 0 to 2 pi. Furthermore, what we're going to do is we're going to focus on solving trig equations where we can use linear properties and solve them just like we would any linear type of equation. So before we begin with some examples, we are going to have a procedure that we're going to follow. The very first thing we want to do is very common to what we've done in a lot of our solving strategies, and that's to isolate whatever it is we are solving for. And in this case, we're solving for the trig function, so we want to isolate the trig function. Then from there, we're going to use our previous knowledge to determine the quadrants in which we could be in, and then identify our side relationships, and then finally determine not only the reference angles, but all of the solution angles to the given statement. So let's begin with our first example here. In solving our first example, I'm going to add 1 to both sides, and I'm going to divide by 8. Now, at this point, it's a good time just to double check your answer to see, does it make sense? Given that cosine is the relationship of the adjacent side of the hypotenuse, I want to make sure that my value that it's equal to is less than 1, because I know cosine has to have an absolute value that is less than 1. In this case, it does, it's 1/2. So I can go ahead and proceed. But if this said cosine x equals 2, I could stop and I know that there's no real solution because it's over the value of what cosine could be equal to. Now, in answering this question, we have now checked off isolating the trig function. Now I got to figure out what quadrants can I be in. So I remember cosine is the x component. And so since I have the fraction 1/2, that means our x value is positive. So I know I'm in quadrants 1 and 4. Now, identify the side relationships. X, R. So I know that my x component is 1. I know my radius is 2. That then tells me that I'm talking about a 1, 2, square root of 3 special right triangle, or in other words, a 30, 60, 90 special right triangle. Hopefully my board resets here. As we're waiting for the board to reset, realize that whenever I'm talking about a 30, 60, 90 special right triangle, I can identify what my reference angle is based off of what side is opposite. There we go. And so now I know that opposite the square root of 3 is going to be pi over 3, or our 60-degree angle. So then this is going to tell us then finally that we have our reference angles. Now I have to come up with the actual angles. So one of my solutions is going to be x equals pi over 3, because we're in quadrant 1. The other solution is going to be such that I'm pi over 3 away from doing one rotation. One rotation is 2 pi. So if I take 2 pi minus pi over 3, that's going to leave me with 5 pi over 3. Sometimes what I like doing that helps me out is I envision, instead of saying 2 pi for a full rotation, I know 2 pi is actually the same thing as saying 6 pi over 3. So therefore, 6 pi over 3 minus 1 pi over 3 takes me to 5 pi over 3. And we can see that here we have 2 solutions to our given statement. Let's try another example down here. And I'm just going to get rid of that. And here we go. Step number 1, we're going to go ahead and isolate our trig functions. So I get cosecant x. Adding 3/4 to both sides is going to give me -4 over 4, which is equal to -1. And then I'm going to be multiplying both sides by 2. So cosecant x equals -2. Now, as I was alluding to previously, with cosine, we said, all right, well, we can't have a value, bigger than 1, but with cosecant, I'm allowed to have a value bigger than 1 because it's the hypotenuse divided by the opposite side. So I am going to proceed in this case, and I'm going to go ahead and draw and say, since cosecant is the reciprocal of sine, I know I'm working in the bottom 2 quadrants. I know my radius is 2, my opposite side is -1, and here is where my square root of 3's would be. From there I get my reference angle this time as being pi, not over 3, This is going to be pi over 6. Or in other words, the 30-degree angle. So now my two angles in this case are going to be pi plus a pi over 6, which is 7 pi over 6. And we would have 2 pi over 6 minus pi over 6, which is 11 pi over 6. So you can see again, we get two solutions based off of how we evaluated them using the reference angle. And then finally, let's go ahead and take a look at our last example. We have cotangent. So I'm going to start off, in this case, subtracting 5 square root of 3 to both sides, which gives me negative 8 square root of 3. Divide both sides by 8. Gives me negative square root of 3. And now this is cotangent. And cotangent and tangent are usually kind of unique because they work more so on a diagonal. And we know cotangent is negative in quadrants 2 and 4. Furthermore, our side relationship, we have our adjacent side, or our x over our y. So this is going to be where we would have the following. So now again, we have the same reference angle as before. This could be pi over 6, but we're in different quadrants. So this time, I'm going to get x is 5 pi over 6, and then I still again get that 11 pi over 6. And if you need to, again, sometimes that trick is saying, all right, instead of pi, I can use 6 pi over 6 and 12 pi over 6 to make it real nice and easy to see my fraction work.